Back again, soon I'll need a new series. So in the last video I showed you why this image was Venus. I'm back to show you that it's still Venus, no matter how often you use the map to say otherwise. First of all, this map is a representation. The scales of the orbits are accurate. These numbers represent astronomical units, by the way. But the scale between the sizes of the planets and the Sun, for example, isn't so accurate. Now I know you're all smart enough to know that the Sun is an awful lot bigger than Venus, but is it big enough to block out Venus from the view of the stereo A satellite? This dotted line represents the angular displacement from the Sun of each satellite. It does not show the satellite's field of view. Indeed, each instrument on the satellite looks at a different aspect of the Sun, and in turn each has a different line of sight and field of view. Some do look straight at it along the line, but some look more towards the Earth, to look out for solar storms and so on, the Sun itself not even entering their view. Stereo A's Core 2 instrument looks directly at the Sun, and because it's studying the solar corona, its field of view has to be large enough to capture the larger events. Let's look at the recent imagery we all know and love. In the same amount of space that Core 2 looks at, we can fit 15 suns side by side. That's a distance of 7 suns either side. It is nearly 21 million kilometres end to end, to give you a sense of scale. Now that wasn't brilliantly scientific, but remember it for later on. The key issue that you seem to have trouble with is that you say Venus is behind the Sun on this map, such that Stereo A cannot see it at all. But we know that this map has an issue of scale, so we need to look at this scene more accurately. I've said before, and I'll say again, that these things can be independently checked with other pieces of software, both online and off, and my application of choice is Celestia. This is a view in Celestia, looking straight down at the Sun, mirroring the view of our stereo map. We can check this by overlaying the stereo map, and sure enough, the orbit and positions of the planets line up nicely. We now know then where the stereo satellites are in relation to this Celestia image, and, importantly, Celestia has an accurate depiction of scale. What we can then do is the ever-scientific drawing a line over the top. Here's our first line, over the top of the stereo map. We're going from the centre of the red dot to the centre of Venus's dot, or at least as close as we can get. Already we can see that we cut through the dot representing the Sun, but we know these scales aren't accurate. How big is the Sun really? Will it be this big in Celestia, therefore blocking our view of Venus? Let's reduce the opacity of this layer and find out. Ah, that's interesting. Our line, the very same line from the stereo map, from centre to centre, does not go through the Sun. It doesn't get anywhere near it. Stereo A's Core 2 isn't looking down our newly drawn line, however, but straight at the Sun. If you remember, our field of view is equal to 15 suns side by side. What do 15 suns side by side look like in Celestia? They look like this, which gives us an estimation for our field of view from Stereo A to be this red cone. Our line from centre to centre is well inside the field of view for Core 2, and at the other end of it, Venus is well inside too. This line goes through the centre of the Sun to show you how far Venus is to the right from Stereo A's viewpoint. Venus is where it should be, it always has been, and now you know, once again, what this object in the recent imagery from Stereo is. That's stereo, not SOHO, as some of you have said. SOHO is a different satellite. It has a different viewpoint to that of both stereo satellites. The name and instrument is stamped into each image. There is no excuse for you not knowing where the imagery came from. So could you please do a little bit of research next time? Thanks.